Alright, boys and girls, welcome to our third video lesson in Chapter 6. Our lesson on proving quadrilaterals are parallelograms. Alrighty, here we go. Okay, there are 5 ways to prove a quadrilateral is a parallelogram. The first one is basically the definition of the parallelogram is that if both pairs of opposite sides are parallel, then our quad is a pair. Okay, number 2 is both pairs of opposite sides are congruent. That's the converse of the property that we know about pairs. Number 3, this is a new one. One pair of opposite sides are both pair and congruent. 4, we already know this. This is one of the properties. If the diagonals bisect each other, then our quad is a pair. And number 5, we also know this. If both pairs of opposite angles are congruent, then we have a pair. So, which one of these down here are pairs? Let's look at the first one right here. Is quad a pair? Yes, it is, because the diagonals both bisect each other, so it's by reason number 4. Number 2, this one right here, is this a pair? Yes, it is, and that is because both pairs of opposite sides are congruent. That's number 2. Number 3, well, this side is parallel to this side. That's given. These two angles are congruent. Notice that they are alternate interior angles, so then therefore this line is parallel to this line. So both pairs of opposite sides are parallel, so therefore my quad is a parallelogram. And numero quattro, number 4, that's this guy right here, is this quadrilateral a pair? Well, it may or it may not be. We don't know. It looks like number 3, where one pair of opposite sides are both parallel and congruent, but in this case, one pair is parallel and one pair of sides is congruent. It must be the same side is both opposite. The same pair of sides is both congruent and would have to be parallel. So we would have to have this side parallel to this side to make that a parallelogram. Okay, I can't wait for tomorrow. We're going to play a game. Pair or not a pair. I just wanted to show you this line because I can't wait. Alright, let's look at this problem right here. We want to prove that my given quadrilateral is a parallelogram. The first thing I'm going to do is I'm just going to label my sides, or my points, I should say. So A is 3, 3, so that's A. B is 8, 2, so that's B. C is 6, -1, so that's C. And this guy right here is 1, 0, that's D. What we're going to do is we are going to find the distance of each of these sides, and if the opposite sides are congruent, then it is a parallelogram. So let's first of all find the distance from A to B. So using my distance formula from A to B, I'm going to have the square root of 8 minus 3, the difference of the x's, which is 5 squared. And the difference of my y's would be 2 minus 3, which is -1 squared. So that was AB. Let's now find this distance, CD, see if it is the same. So I'm going to first find the difference of my x's, which is 6 minus 1, which is 5 squared. I'm going to find the difference of my y's, which is -1 minus 0, which is -1. We don't even need to do the math here, but we're going to get root 26 for both of these distances. So it looks like those two sides, opposite sides, are equal. It's root 26. You can just look at the radicals too and see that they are equal. And now let's do sides AD. Well, the difference of, so I'm going to take the square root of that, right? The distance of my x's from A to D is 3 minus 1, so that's 2 squared, plus the difference of my y's, which is 3 minus 0, which is 3 squared. Now let's do BC. The difference of my x's, 8 minus 6, is 2 squared. The difference of my y's is 2 minus 1, which is 3. So again, we see we have the same radical. Not that it's important in this case, but these are both radical 13. So this is a parallelogram because opposite sides are congruent. Both pairs of opposite sides. Check. It is a pair. Let's do another one here. This time we're going to prove that this is a quadrilateral. We're going to use the midpoint formula. In fact, what we're going to do is we're going to show that the two diagonals bisect each other. If I can show that they have both diagonals have the same midpoints, that means that the diagonals bisect each other. So first of all, let's label my points. So F is -2, 4, so that's F. G is 4, 2, so that's G. H is 4, -2, so that's H. And J is -2, -1, so that guy's J right here. Let's find the midpoint of FH. And again, if you remember the midpoint formula, I'm going to add the x's. So FH is going to be -2 plus 4, which is 2, over 2. Okay, let me just erase it. I don't know why I put that there. So there is my x coordinate, which is, of course, 1. My y coordinate for the midpoint of FH is going to be the sum of my y's, which is 4 plus -2, which is 2, over 2 equals 1. So the ordered pair for the midpoint of FH is 1, 1. If we find the same midpoint for GJ, then we know that this is a parallelogram because the diagonals have bisected each other. So let's look at GJ now. Let's look at the x's first. 4 plus -2 is 2. 2 over 2 equals 1. And let's look at the y's. 2 plus -1 is, let's get this right here, GJ, 2 plus -1 is 1, over 2 is 1/2. Well, my ordered pair for this one now is 1, 1/2. So guess what, folks? This is not a parallelogram. The diagonals do not bisect each other. Okay, let's do a proof now. Let's prove RSTV is a parallelogram. We're going to do this by proving both pairs of opposite sides are parallel. So therefore now we have our givens. Angle XRV is congruent to angle RST. So RST is this angle right here, and that's congruent to XRV. We also have now that angle RSV, this guy, is congruent to angle TVS, this guy. Okay, so there were our givens. That's our first step. Our next step is we're going to say, okay, well, if angle TSR is congruent to angle XRV, the red angle is right there. We see the corresponding angles. In fact, we see this big letter F right here. We have corresponding angles, so therefore ST is parallel to VR, and the reason is congruent corresponding angles yield parallel lines. And now we can also look at step 3. The blue angles right here, and they're now purple. Those angles are alternate interior angles. So if those angles are congruent, then TV is parallel to SR. So I can write TV is parallel to SR. And the reason for that is congruent AIAs yield parallel lines. I can now write in step 4 that RSTV is pair, and the reason is two pairs of parallel sides yield parallelogram. I'm sorry my writing's so bad. It just still working on this iPad thing. All right, let's do one more. All right, I'm not going to write this one out for you, but we're going to run through it. Let's look at the givens. AF is parallel to EC, so that means that this line is parallel to this line, which now means that angle 4 is congruent to angle 1 because those are alternate exterior angles. Okay. We also have that AF is congruent to EC. So far I have actually, if you look at these two little triangles, AFB and triangle DEC, those triangles we're going to try to get congruent. So far we have a side and an angle. Well, if I know that BE is congruent to FD, I can subtract this middle piece from both of them. So we're going to have to do 2 steps to prove that these two sides are also now equal. Okay, we're going to have a BOP step, and we're going to have a subtraction property in there, and we're actually going to have a reflexive because we're going to say that FE is congruent to itself. So we're going to have a bunch of steps there. But once I've done that, I now have that those two triangles are congruent by side, angle, side. Which means now once I have that, angle 2 is congruent to angle 3 by CPCTC, which means this side is going to be parallel to this side by congruent alternate interior angles yield parallel lines, and also by CPCTC, this side is congruent to that side. So I have a pair of sides that are both congruent and parallel, which then leads me to having a parallelogram. Just to give you one idea, this is going to be a 7 or 8 step proof. We're going to have our givens. If you remember now, we had alternate exterior angles, so we had parallel lines yield congruent AEAs. If you remember, we had a BOPs. We had a reflexive. We had a subtraction prop. Those triangles were congruent by SAS. Going over here now, we had a CPCTC, and we're actually going to say 2 things, both the angles 3 and 2, and the sides, A, B, and CD. And then lastly, we're going to have the fact that congruent and parallel sides yield a pair. So that's an 8 step proof. Alrighty, have a great day, and we'll see you mañana.